This is the model ET9500 tube and pipe bending machine. Has a 15 horsepower motor, 5,000 psi hydraulic pump. It's electrical driven and hydraulic powered. It's 230, 440 volts, 3-phase. It's a semi-automatic bending cycle. You can bend with the foot pedals manually or semi-automatic forward and reverse. It's a heavy-duty machine for bending pipe, and it can bend up to a half-inch pipe or half-inch. It can bend up to 2.5-inch pipe with half-inch wall. Its capabilities of bending up to 6-inch radius, which is the largest, or a 3-inch radius, which is the smallest. We're looking at the sequence valve, and the sequence valve is used for counterbalance pressure on the bottom cylinder. At 5,000 psi, this machine can generate up to 80 tons of bending forces. It's driven by a piston pump rated at 5,000 psi. We're looking at the relief valve that sets the system pressure. The dies are easily mounted, and on the rear stroke there's a micro switch that'll stop the rear stroke, and there's a micro switch on the bottom that'll stop the forward stroke. Some K-prene or polyurethane pads to protect the operators from ever getting their hands caught in between the gates when they're closing. This is the depth of bend plate, and there's a handle there where you set the depth you want to bend. Okay, now we're going to set the depth of bend plate to 90 degrees. He's going to turn on the machine. And what he'll do is the control box is in the front there. He'll hit the start button. It's going to go forward to 90 degrees. And when it hits 90 degrees on the bottom, it'll automatically stop at 90 degrees, retract, and then it'll go all the way back until it makes a rear micro switch, and then it stops. We're going to operate it with the foot pedals, and if he hits the left foot pedal, the bending dial will go forward, and it'll bend to whatever degree he wants and stops, and then he hits the other foot pedal, and then it'll come back and retract and stop. We're going to do an automatic cycle again. When he hits the button, it's going to come back and it's going to make a bend. And you can see the safety guards protect it, and then he'll come back with it now. And the operator can't get his fingers in there, and it's to protect the operator from getting pinched. We've tried to made every effort to protect against all the pinch points. We're looking at the dies that come with the machine. These particular dies are, there's a 1-inch diameter, a 1 3/4-inch diameter, 2-inch diameter, and a 2.5-inch diameter. And they'll all bend pretty close to 180 degrees. When you're using the 3-inch radius dies, you have to have those spacers. You'll look at the spacers right there in the back of the back shoes. Those spacers have to be placed on the machine in between the back gate and the back shoes. This allows for the dies to maintain contact, or the bending dies or wing dies to maintain contact when the bend is being made around the bending die or the radius die. They're simply bolted on from the back with socket head cap screws, and they're bolted onto the gates, and here's a hole in the front of the gates. He's going to install the 180-degree die on the pusher block. He bolts it down again with a socket head cap screw. Tightens it with the Allen wrench. Install the spacers. And these spacers have to be used when you're bending the smaller radius. You can see there's a hole in spacers where the socket head cap screw will go through it. Now he'll install the wing dies. Now he'll install the wing dies, and he'll bolt it in from the back side. Notice that there's a little radius on that wing die, and when you assemble these dies, be sure that the radiuses are towards the inside as they're being installed. It's important that these radiuses go on the inside. Do not put the other sides. And when you use these, you have the longer socket head cap screws, so they go through the spacers and bolt onto the dies. Tighten. You should be sure that they're tightened so that you can get them good and snug up against the back plate. Bending any pipes or tubing, it's important that the tubing or the pipe be as clean as possible. It creates a problem when there's a lot of rust or scale on the pipe. For this reason now, he's going to put a lot of grease on the wing dies, and you should put this grease on there for making every bend. Now you can see that we have a good amount of grease on the wing dies and the bending die. It's very important to lubricate these dies for making every bend. We're going to make a bend here. This is a 1 3/4 heavy wall pipe. You'll turn on the machine now. And now he's going to place the pipe inside the dies, right up against the wing dies. And now he'll proceed to make a bend. Now we're going to just keep on bending here to 180 degrees. And the die will come all the way out and it'll stop. You never go beyond the bending die with the wing dies. Now this here is approximately 175 degrees. Any further, Ralph?
Yeah, I can go maybe 2 inches.
Okay, go ahead. Go ahead. The noise you heard was just the pressure of the dies on the steel. Now, because these are so far beyond the center of bend, where the bending dies beyond, almost beyond the, or almost to the end of the wing dies, there's a tool that we have to put on to retract the tube back to get it clear before the gates can close. Notice that each gate has a threaded stud going through it with a nut on the back of it. You get a look at them right there. What those are for is to align the gates so that they're parallel to each other. And you can adjust them so that when the gates are parallel, then you lock them with a nut in the back there. You get a look at the chains that we use on these, on the gates, on the back gates. Both gates have chains that are heavy duty, and they're rated at 39,000 psi of tensile strength. Now we're getting a look at the tool that we use to retract the tube back so that it can clear far enough so that the gates will close. When you're making a deep bend, you have to use this tool in order to get the tube back. It is very, very important that the socket head cap screw that is holding the die, the bending die in place, should be removed before you put this on. Now you only need to use this this tool only when you're making a bend that is deeper than, say, approximately 120 degrees. You'll notice here the bolt that holds down the bending die has been taken off, and the reason for this is there's some play on the tool, so that when we start retracting the tube and pull it free from the bending dies or the wing dies, we could bend that bolt, so it's necessary to remove it. Okay, now that we've got that tool on there, now he'll just go ahead and retract it. And you only go back so far until you know the tube is going to be clear and that the gates will close. Then you remove it, and then you continue to go backwards. Okay, now we're just going to keep coming back until the gates, so we know that the tube is clear, and then he'll stop before it goes too far. Now he'll remove the tool, and now you can just continue to close the gates. And you have to come all the way back, and then when you stop, you have to lift the die out with the tube. Then the die is out, and there's the bend. I would say you probably have about 100 and maybe 75 degrees right there. Now you can see the bend there, and that die made that bend, and here's a variety of other bends. Right there we have 1 3/4, 1 inch, and 2.5 inch, and you can see the heavy wall.
No, it's okay. Turn them around.
Now we're looking at a flow control valve here, and the purpose of this valve is to create back pressure when the cylinder is retracting. If you screw it in, you'll increase the back pressure, and that back pressure is sent down to the bottom cylinder. And when you screw that in, or the more you screw it in, the more back pressure you're going to have, and you'll read that back pressure on this gauge here in the sequence valve when the cylinder is retracting. It's used to increase counterbalance pressure. It diverts flow down to the bottom cylinder, or restricts flow from the bottom cylinder to put more counter pressure when you're making a bend. The fact that this is heavy wall pipe, you don't need much sequence valve or counterbalance pressure. And to adjust the counterbalance pressure, you simply screw in the hand knob in the front, and that'll increase the pressure. Turn it out counterclockwise, it'll decrease the pressure. Now we're looking at the solenoid valve. It's a 4-way solenoid valve. We're looking at the pump. There's the relief valve, which sets the system pressure. And there's another little knob here on the pump. Hope it comes out clear enough so that you can see that also adjusts the pressure for the compensation on the pump. It's a pressure compensated piston pump. You'll notice that there's a hose coming out of that pump that goes into the tank right here. That is a purge line. If you ever do any work on the pump and you take this hose out, or you rework the pump for any reason, before you turn this pump on, you must remove that hose and you must fill the pump with oil. It's a piston pump, and unless you fill it with oil, you'll do damage to the pump. If you'll notice on the pump, there is a red arrow, and it's pointing downward. That arrow is the rotation of the pump or the motor. And to check the rotation, when you plug it in, there's a little cover on the pump housing, motor to pump housing. Remove that. It's very important that this pump runs in the right direction. If you prolong the run in the wrong direction, you'll do damage to the pump. Your service manual will tell you how to change the rotation on the motor. It's very easy. The oil fill cap, and that's where you fill the reservoir with oil. And then down here we're looking at the gauge for the reservoir, and it'll tell you the oil level that you have in the reservoir. Filter. This unit has a strain filter where it sucks oil from the tank, and then this filter here filters the oil going back into the tank while it's circulating. This is the 220 horsepower, 220 volt starter, motor starter. Here you see there's an arm. You see that there's an arm here on this depth of vent plate, so when he goes forward, he can jog it to where he wants to go to and then stop at any point that he wants. This is what you would use when you're making a prototype bend. And you'll read the degrees on there and bend 10, 20, 30, whatever degrees you want. And then he just retracts it and it'll come back. It just automatically, not automatically, but it'll come back to zero and start from zero. Here's a 12 volt automatic control system designed by AMH. When he hits the blue button, it'll come forward and it'll start making a bend cycle, you can see. And then when he comes and hits a red button, it'll automatically stop and then automatically retract. And it'll retract and keep going back until the rear micro switch is made, and then it'll stop automatically.